Hello everyone, welcome back to this RS series in JavaScript. And today's question, we have a follow-up of the previous question, that is intersection of two sorted arrays. We are given a input array A and input array B. If you see intersection means the elements which are commonly present in both the 0, 0 present, 1 not there, 2, yes, we have 2. That's it. So this is your output. Okay. So if we see how do we solve this? Okay. Last class, if you remember, we had discussed of a two-pointer theorem. Remember two-pointer theorem? And we will directly implement this question with that method only. Okay. Let's do this. We will take a pointer I over here and a pointer j. Okay. Let's take n1 is the length of this array and n2 is the length of this array. Okay. Now we'll start this iteration from here to n1, here to n2. And we'll make sure intersection means if the loop ends, that is it. Okay, so that means the condition will be like we have to perform this while I is less than n1 and I is less than n2. Okay, first this one. Now in this we have like obviously there will be an input array A, which sorry output array A, which we will return at the end. Now we have to check the elements which are common, like for both I and j. Okay, so the first condition I can take is if A of I equal to P of j. Okay, if it will be equal, then what we will do? We will array dot push anyone you can take A of I, and if it has been pushed, then that means we have to increment also. We have to do this increment, then I plus plus and j plus plus. This is it. Next, if it is less than A of I is less than B of j. If A of I is less than B of j, like 0, let's suppose I can take 0 less than 1, then which we will increase? Obviously, we will increase this one because this is greater, right? Then here in this case, what we will do? I plus plus. If A of I is greater than B of j, now which is lesser? J is lesser. So we will do increment j plus plus. That's it. No more operation we need. And so this was a very easy. If we talk of the time complexity, then I can say the time complexity will be at max like minimum of n1 and n2, minimum of n1 and 2. You know? So I can say minimum big O of whichever is smaller. So I can say let's take in general big O of n, but to be precise, whichever will be smaller. Are we consuming any space? Yes, we are consuming. So the space complexity here I let space complexity will be again big O of what? Big O of whichever will be smaller, to be more precise. At max, I can say whichever will be smaller. It might be that all the elements of n2 is present in n1 and n2 is lesser than n1. So all output will be this one only. Okay. So but in general I say then big O of n. But to be more precise, max less and whichever is smaller, big O of that. Okay. That's it. This was a very easy question. Thank you. If you are still tuned, like and subscribe to this channel. Thank you.